recording the capsule imaging data analysis on dorsal organ worm cells. Okay, a couple of files you need to open and check. And first is our user menu, and then is the capsule imaging notes. After that, we need to open a couple of folders, and your sample folder, you can find it from the data, and the date is 2024, August 20, and you have DOWC001. We are working on our example folder. Another one I want you to open is the example folder. In the example folder, it is empty files with the correct file structure. Okay, before the analysis, we want to check the maximum projection TIFF file. It is showing from our user menu, so we want to visualizing the neuron response in ImageJ. Open your ImageJ, and you just simply drop your maximum projection file into ImageJ. You have the microscope picture opened. First thing we want to do is adjust the brightness to allow you to see the cells better. Come to ImageJ, Image, Adjust Brightness. So you click Reset and adjust the maximum toolbar until you can see the sample clear. Now, you need to compare with the notes I gave it to you. So in this picture, I show you what our two neuron cells are, and the top one is neuron 0, the bottom one is neuron 1. Okay, this is the cell body, and then you see the dendrite, and you have a little dot, that's dendrite bulb. We only analyze the cell bodies. Okay, and the picture I get is from different time points. Start with 12, and the temperature start cooling. With cooling, you see the cells fluorescence decrease, and then at 24 we start warming. So you see the cell response, it getting brighter, and then another cooling. Okay, comparing to your maximum projection, and you play with the progressing bar, come to, this is the time points 12, you see two warm cells, top one neuron 0, bottom one neuron 1, and then with the timing and the cooling progressing, and you see the cells fluorescence decrease until 24 we start warming and their fluorescence increase. So this is a warm response, which is normal, and our wild type control the warm cell response. Okay, from this maximum projection pictures, you also see the movement of the animals. If the animals are running aloud, wandering around in your view, and trackmate cannot catch it, so which we need to do the manual analysis. But for this sample, we can use trackmate to check the cells. Okay, now close your maximum projection. We start to do the analysis. So I have two folder opened. Okay, and we want to copy the analysis folder. The shortcut for Mac is Command C. For Windows, I believe it's Control C. And then paste. Under your main sample folder, okay, you see the correct structure where you should paste analysis folder. Now let's check the analysis folder. We have empty file but correct file structures. So you have a background file, 3 neurons, and if worm cell will only have 2 neurons, you can delete the second one. And now let's open the background file, leave it aside. We will fill in the background data while analysis stacks. Okay, good. So next is we come to our stacks. I like to start in the center if I only have one DOG showing here, which will have more chance to see those two cells better. So let's start with 0, stacks 10, and put that into your ImageJ. If the place is correct, you see the drag and drop showing. Okay, releasing it. Click Reset. Adjust the brightness until you can see the cells better. Okay, good. Now come to our ImageJ plug in checking checkmate. The first message, we need to spell Z and T. Click yes. And this window, you need to check the time points. We have 88 time points. If you start from T0, then it will end at 87. That is correct. Okay, next. So here, this window, we choose DOG detect. Next, the diameter of our object we need to test. Let's see 18. You click preview. Okay, I found a lot of circles on the screen, right? Those are the possible cells checkmate think. I think I like to try 7. Okay, I think we want to circle the shorter part of the diameters of that cell, okay? And then you click next. Oh, one thing, the quality threshold for very beautiful, strong fluorescence warm cells, we start with 1. For some mutant cells, if the signals overall, the signals are weak, then we need to lower the numbers in order to select all the cells in our view, okay? Now we click these 2 choices, and then next. It takes some time, depends on your computer system, okay? But you need to wait until this progress is finished. And then click next. We don't do anything here. Next. It comes to the most important part of to setting the filters on spots. Okay. The idea is I set correct the filter and try my best to only select my candidate cells. Okay, here is neuron 1, neuron 0. We start from 0 to 1, yes? First, we can set the filter by X and Y. Let's start with X. So you see you can play with it above or below. Let's start with above. You play with the bar, you see how the filter works, right? Because I'm working on neuron 0, let's do this way. Okay, now I set the other direction of X. So play with it and narrow down the X value. Okay, now I can set by Y direction, so to move the cells out. Good. And then I set another direction for Y. I see something below, filter those cells out. Okay, see I need to filter the cells out. Good. In this point, it looks like select only our neuron 0. However, because the animal is moving, we need to check for all the time points from 0 to 87. Okay. No, it's showing from 1 to 88. When I play with it, you see it move a little bit and 2 circles pop up. I think, okay. So something I want to check to see the weakest part. We have something quite weak. Okay, good. So let's see if I can manually to adjust it better. So like this point, we need to adjust the Y axis above to move it down. Okay, good. So I'm not sure if this one, let's work on X. Okay. Let's see that another direction. Good. Oh, you see here, because the setting of filter, I'm losing very important time points here. So which means I need to find it. Not X, then it is Y. Let's see. No. Okay, now I see it. You need to play with this filter until you think that's the best you can do, okay? If still some extra circles showing, then we can delete them in the Excel, yeah. The goal is, you can see it by your eyes, and then this neuron 0 should be selected by the checkmate, okay? So I want to get idea of the movement. So I'm moving down. Let's see. Okay. Here, I think I may play with the quality filter. This is the quality. Let's see. Okay, I'm playing it by each time points, okay? Oh, no. So here, I need to select it. I think the animal moved down, and we need wider the Y filtering, and then so there's some extra like neuron 1 over here selected. However, because the moment I cannot get it better by setting the different filters, so which means I need to delete them later on from Excel. Okay, that's the best I can do. I want to make sure all the time points of neuron 0 is selected for the case I can see it, okay? Good. Good. Okay, the first setting should be very carefully and to make sure I select all the neuron 0, okay? Good, I click next. Here we just choose simple LAP checker, next. This number you need to remember is 110, 110, and 15. And then next, 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 you just click next. So here is to show display checks or not, and display the spouts or not. I like to unclick this part, and then you click spot. You get a table pop up. So first thing I want to do is come here, click checking ID. The checkmate will help you to sort the neurons based on the movement, okay? But it's not intelligent. We have to check one by one manually. So we need to export the CSV. It is in the data DOWC. You see the folder analysis we just copied. This is neuron 0. You need to give the correct file name. This is very important. It is mean intensity, and the stack is Z10. No, Z, mean intensity 10. Format the CSV, save. Okay, now you save it to your local folder. Come to neuron 0. That's the file we just saved. So open with Microsoft. Next, the first thing is to delete the extra header generated from image.j. Delete. We only keep the top. You see you have label, ID, tracking ID, you have position T, and you have the mean intensity. This is the final data we will use, okay? Okay. Now we need to clean up this Excel to delete all the wrong selections. Come back to your image.j. I will check this one by one, okay? From the top, the green circle shows these time points, the cell, what they are is here, here. Definitely those are neuron 1, so we need to delete and come back to our Excel. Checking ID, there we have 2 datas, no checking ID, that's neuron 1, and then let's delete them. Delete. Okay, now come to see all the tracking ID, which is 0 from here, and see this green circle shows what those selection are. Okay, you see from the spot ID 3149 until 3620, those are the wrong cells. Okay, I will find the 3620 is here, so we delete all those status. Okay, start from 3512, come back to image J. Is our neuron 0? Yes. Okay, good. Those are all correct neuron 0 selection. And then come to this is wrong, 3406 until the checking ID, which is number 2, number 3. Those are all wrong cells, right? I think it starts from 3406. I need to look for this number. Come back to your Excel, select the column named ID and open Command F, open your find. The number is 3406. You tap in 3406. So find it in your document. Start from here to the end. Those are the wrong cells we delete. Now we have all the correct neuron 1 in the table, but because it's sorted by tracking ID, okay, we have 2 tracking ID here. We need to sort this table again based I position T, then from 1 to 88. And how to do sorting on Excel? You come to Data, Sort. The windows pop up. We select position T. From smallest to largest, click OK. You see? Now it's the right order from position T from 0 to 87. Okay. And then the next step is very important. We want to check the duplicates. Sometimes one time points one cell, they will have 2 circles. So conditional formatting, highlight cell rules, duplicate value, and we want to use red color to represent the duplicates. Click OK. Double check. For this sample right now, Z stack 10, we have no replicates. And you have a look at the mean intensity. So it's around 500, 600, 100. Okay. This one, then click Save. Next, we need to get 5 background for neuron 0. Okay. I want to zoom. The shortcut for zoom is click plus button, and your mouse should be nearby your cell with the area you want to zoom. Okay, now I need to draw a circle. So you select the circle button, you hold the shift on your keyboard, and you draw a circle which has the same diameter with your cell. Okay, I think I set my setting is 17. Okay, so you see it showing here, and then I place this not overlapping with my cell, but not too far, and I make sure it has no influence from our cell's fluorescence, but this is the background signal. Then come to time point 12, adjust the cell, click M on your keyboard, that's the measure. Okay, first time point, next is 24, the second 36, and then 60, 5 time points, okay? Good, you have 5 background data, and select all of them. Command C, copy, come to your background file already opened, paste it. I only want to copy the mean intensity. Paste it to neuron 0 stack 10. Okay, in the class I also paste it to neuron 1 because I know I see it, but be safe. Let's make sure no mistake. And in the beginning you just put it in which neuron you work with. Okay, so don't forget to save it and put it aside. This stack I finished. So let's close this window, then we will check the neighboring stacks. We finished 0, 10, now let's see 0, 9. To have an idea how this stack is, let's go back to compare the same time points. So for example, like number 11, and this is a come to 11. Okay, same time points. Yes, you see Z stack 9, the signal is getting weaker. Okay, so which means the scanning is moving from the center to the top or bottom. Okay, so you need to have idea how the scanning is. Yeah, that is come quite center. So there's a weaker, but we still need to analyze them. The same thing as the first stack. Checkmate. Open checkmate. Yes. Preview. Sometimes you see the little dots. This is a bug from the checkmate. You just move the progressing bar a little bit and then click preview. So because the signals are getting weaker for this stack, and I need to adjust the diameters a little bit, I think that works better. So remember, this is 16, it's not 17 anymore. Okay, next. Sometimes you have this popping up arrow from Java. Ignore it. You can continue to do the analysis. Okay. After the first setting and the filtering, we need to adjust, but not too much. Yes. So I think this point maybe I can play with the quality. Can it be a little bit lower? Okay, good. So we have some wrong selection, but that's not a problem. We will delete them in Excel. Okay, so click next. Export the data, sort by checking ID, save it to neuron 0, and now we are working on stack 9. Save. Okay, so come back to the folder, stack 9, delete. And now let's start to clean the table. Okay, so let's check. The first two are wrong, and and then this is correct. So at this moment, let's delete only the top 2 data. Okay, let's continue. This is neuron 0, all correct. Okay, they are all neuron 0 for checking ID 0. start from checking ID 1. That is wrong. Okay, and then we have neuron 1 selected. This is also wrong because we are working on neuron 0 and also 3. Okay, for this stack, it's easier. So we just delete all the checking ID with 1, 2, and 3. Come to our Excel. Then delete this one. Delete. Next is come to position T, and you see the sorting is correct from 0 to 7. And then we check the duplicates. No duplicates. The data makes sense. Save. So we finish Z stack 0, 9. Good. And background. Okay. Circle toolbar. Hold Shift. Draw a circle. This time is 16. Come to time points 12. 24. 36. 48. 60. Okay. Where's my measuring? Here. Copy. Background file. Paste. Mean intensity. This is stack 9. Save. So 9 finished. Let's continue. Z stack 8. You see it's getting weaker and weaker, yeah? We come to checkmate. That's the same repeating work, okay? If you see dots and you just move a little bit, it doesn't matter how much you move, okay? You click preview again. Normally, sometimes we need to run it twice. I think 16 for the stack still work. I will keep it. Next. Let's see. You want to make sure you have some extra wrong selection. That's okay. We will clean the Excel, what you see I did many times. But you want to make sure all the neuron 0 is selected. Okay. Sort by checking ID. And export. Now we are working on number 8. Same thing, delete the top row. Header. Okay. Good. Let's start cleaning. We have some of with no checking ID. That's all wrong selection. Let's start from 0. That's neuron 0 is correct. Oh, okay, this is a little bit complicated. So 0, 0, 0, 0, 0. This is wrong. And then how many? So 2 neuron 0 is wrong. Okay, the last two, come to your Excel. Last two I delete. And then checking ID number 1. This is wrong. 2 of them are wrong. Delete this 2. From 42, 7, 41. 42, 7, 41. That's neuron 0. Correct again. Okay, good. So all checking ID number 1, that's correct. Then number 2 is wrong. Number 3 is wrong. 2 and 3 we need to delete. So okay, we have 2 checking ID here. Definitely we need to sort by position T. Okay, sorting data, sort position T. Okay, then we check duplicates. See here we have a duplicate on position T equals 17. And I need to check which data we save and which data we delete. Okay, you come back to your image J and you pull the progressing bar to 17. Interesting. We have 117 here. The numbers mean intensity is 246. And then we have another 70. This is wrong. Okay. We need to delete this one, okay? So we need to keep the higher value and delete the lower one. Okay, delete. Now we have no replicates. Save this file. We've done this part. So work with the background. I like to zoom, draw the circle, 16, time point 12. First background, 24, second, 36, $60. Did I miss anything? 24. Make sure you have 5, okay? And the numbers are quite close to each other. So open your background, copy, paste, save. So Z stack 7. Checkmate. Okay, because getting bigger and bigger, so I smaller the diameters of the cells to 15. Okay, let's check the filter. Do I need to adjust? I think no. Okay, we have neuron 0 selected across all the time points. Okay, good. So you just click, move on, spots, sort by checking ID, export. This is Z stack 7. Clean the table. Image J. So the first 4, 5 with no checking ID, those data are wrong, so let's delete. And then start from checking ID 0, that's our neuron 0, this is correct. Okay. So from checking ID number 1, that's neuron 1 we need to delete. Okay. Okay, we only have 3 neuron 1 selected. Let's delete those things. There's only one checking ID, and let me check position T. We don't need to do sorting on this stack, but we need to look for the duplicate. We always need to look for double check with the duplicate. Okay, no duplicates. And mean intensity number makes sense. Save. Good. You see it's getting faster and faster. So background. This is 15. Circle. The diameter is 15 for this stack. And time point 12. $24. 36. 48. 60. Okay, 5 background for Z stack 7. Okay. Finished. 6.
Double check because then otherwise it's gonna relate to like the and could be checking that what's on or you can just delete it, Yeah, sorry about that.
$15 work for this stack. I will keep the setting, and then you just click next. Wait, filtering, let's check again. Start from beginning. So for this stack, because the signal is getting even more bigger, and my quality control need to adjust until you see Now I see this from the time point 19. Okay, let's continue, move on. Good. Sort by checking ID. Export. This is Z stack number 6. Open. Okay, let's check the first. A couple of data with no checking ID. They are all wrong selections. We delete them. So when you work with the stacks, I hope everyone can draw this image in your brain to imagine how the scanning the microscope did. Okay. So you like, so from stack 10 and now it's continuing to scanning upper or lower, but now the center is away to the center, right? Where's my spots? Spots table. Okay, good. 0 is correct. Okay, 0. Checking ID. 0 is correct. So, good. Because they are all belong to checking ID 0, we don't need to do sorting on position T, but we always need to check the duplicates, okay? No duplicates? Then cool. Background. This is 15. Oh, wrong. You can clear here, okay? If that's wrong, I need to adjust to time points 12. Then we start to measure the background, okay? 24. 36. 48. 60. Good. We have 5 background here. Z stack 6. Save. 6 finish. Let's close all these windows for stack 6. Okay. Now we come to see stack 5. As comparing to the previous stacks, okay. If you see any time points, it's getting quite stronger, so you still need to work on it. In the beginning, I think quite weak, but the animal move on Z direction, and I see a brighter spot, so I need to work on Z stack 5. Checking, checkmate. So we need to adjust the quality filter and lower the number in order to see all neuron 0 is selected. Okay, let me see. Okay, good. We get quite clean selection for this stack. Come to see the spots and click tracking ID, export number 5. Okay. Good, this is an easy one. Yes, all neuron 0 is correct. Okay. Duplicates. No duplicates. Save. Finish. Background. Diameter is 15. Okay. Start from number 12. First background. Okay, I have 5 background data. Then put it in Z-stack number 5. Save. Okay. The signals are quite weak in the beginning. Let's see the following time points. I think it's still weaker than the previous Z-stack. I will stop at this moment. Okay, so this direction then we start from 0, 10. Now come to the other direction, Z-stack 11. Oh, I think it's weaker than Z-stack 10. So 10 is really the center of the cell. However, I see a brighter point, so I need to work on this stack. Okay. Checking, checkmate. You should already very familiar with what I'm doing. Let's see. Work. Wait. Let's see, say 16, maybe better. You check the diameter with the cell's shape. I think 16 is better. Okay. This is Z stack 11. No checking ID data are all wrong, so let's delete them. 0. Okay, from number 0, the last 4 are wrong, and then is number 1, sum of correct, sum of wrong. This is correct, so until the last 4 of checking ID 0, and then 4 of number 1. Delete. 1, 2, 6, 8, 4, 7, 5 is correct. This is correct. Okay. Oh, those are correct. Oh. Start from 1, 3, 4, 5, 2, 0. This is wrong. Then let's see the next. And number 2 are wrong. 3. Until 1, 3, 3, 6, 7, 1. Be careful, this is a bit complicated stacks, okay? Make sure you delete the correct one, yeah? 1, 3, 3, 7, 8, 5. This is correct. 4 are wrong. Okay. Because we have multiple tracking ID belong to neuron 1 and we need to do sorting, data sort based on position T. Don't forget to select this. My list has headers, okay? Okay. Now let's check the duplicates. Good. Save. Let's work on the background. 15, 16. This is Z stack 11. Let's check Z stack 12. So neuron 0 is quite weak. I believe across all the time points I have stronger signal from other stack. Okay, then I'm end with the analysis of neuron 0 in checkmate.